Very good afternoon. Welcome to the class, Pooja. So, Pooja, thanks for waiting for the class, dear. We are soon going to start it. How about your studies, dear? Come on, Pooja. How about your studies, beta? How your studies are going on? Tell me. Yes. How is the study going on, dear? Tell me, guys. Am I audible? Am I audible? Tell me. Okay. Yes, please let me know. Am I audible, dear? Okay, done. I'm audible. That's very nice. So, guys, how about your studies? Hope it is all going well. Yes, that's really nice of you all, guys. So, wonderful of all of you guys. So, let us start. Come on, before we are going to start the class, I just want to tell you to share to all your friends faster, because do you know what we are going to study today? Yes, we are going to study resonance and what are the type of actually what are the structures which are actually responsible for causing resonance. We are going to study all that. So share to all your friends, ask them to be here, ask them to join you guys. Welcome, beta. Welcome to the class. Without delay, share to all your friends so that they also can study it, because this is something which has, like, I have been getting requests from all most of the students that, ma'am, please make a video on resonance. And not no doubt I belong to resonance. I worked at resonance, but it is not that resonance, but the resonating structure, because we face a lot of problem while deciding the structure, deciding the stability. So today, your all problems are going to solve regarding that. Don't worry. So I would like to tell you that, come on, share to all your friends, ask them to be here as soon as possible. So once again, a warm welcome to your very own channel. Let's crack NEET UG. Myself, Sharada Alok. I have been teaching chemistry at Resonance from past 10 years. Now, guys, the very first question should be there in your mind, like how to get connected to us. First of all, go to Play Store. It's very simple. Go to Play Store, download the Unacademy learning app. Learning app. Remember, there is educator app as well, but that is for the educators, guys. So download an Academy learning app, then click on to NEET UG and then go for the subscription. But before you go ahead for the subscription, let me tell you what are the benefits of taking plus subscription. First of all, guys, you get daily live classes where you get connected to the educator. You can chat with the educator. You can ask all your doubts with the educator, isn't it, related to the topic being taught on the screen, either, or like any doubt if you have, isn't it? And yes, get it clear all your doubts there itself, and clear all your concepts there itself. Not only that, you'll be asked polls. What is this polls? Let me tell you. You'll be asked questions related to the topic being taught on the screen. And yes, on the very after that, you get your rank in the form of leaderboard in front of your eyes on the screen, guys. That of course going to add a lot of confidence to you. That definitely add a lot of confidence, guys. Okay. Yes, you can enhance your confidence by participating in these live tests as well. These live tests are conducted on a regular basis and plays a major role in building up your confidence, preparing the topic. And yes, they give you a proper evaluation, gradual evaluation of your performance comparing to all your competitors. Okay. And not only that, guys, you'll be having quizzes as well. Of course, they are also going to add a lot of confidence to your academics. But not only that, guys, this is going to sharpen your IQ as well. And yes, this is going to minimize your negative marking because there is a limited time period in which you are supposed to answer. I'm repeating, there is a limited time period in which you are supposed to answer, and then the very next to that, you are going to see your, marks and your improvement, your ranking in the form of leaderboard on the screen. And then you just get a clear cut idea like how much negative you are actually making, or like what actually needs, what extra revision you require for a particular topic so that your negative marking gets minimized. All these introspection are very well given to you yourself by the quiz. Just what you have to do, participate in the quiz. I just want to tell you that Tuesday is a quiz day for an academy. So many quizzes are there, but for that you will have to subscribe the channels. Okay, not only that, weekly also there are so many quizzes, so just be a part of that and just examine yourself, examine your academics, examine your negative marking aptitude as well. And yes, examine your MCQ aptitude as well, that how much positive you are making by the studies you have done so far on a particular topic. And not only that, we are not ending here, guys. We are not ending here. By winning the quiz, you are going to win referral points, out of which you can buy any of the courses running at Unacademy platform of your choice. So these quizzes are so beneficial. You must participate in the quizzes, guys. And yes, here not we are ending. Yes, you'll be getting structured course which are precisely designed by the top educators, looking your requirement, looking all your target, looking all the latest strategies which are to be involved, which should be inculcated while you prepare for the particular exam. Everything you are going to get under this structured course. This is something which has been recently launched by Iconic Subscription. Let me tell you, this is something which has been, welcome Vita, welcome Priya. How are you and your studies? Which has been recently launched by Unacademy. This is what Iconic Subscription. Let me tell you what it is, guys. Iconic Subscription includes this, gives you wonderful features of this is, yes, personal coach. The top educators, yes, guys, you heard me right. The top educators across the nation are going to be your personal coach. And not only that, you're going to get one to one guidance from top exam expert as your personal coach. And you'll be getting a proper preparation strategies, which is going to work very, very well. On the same amount of hard work, you will be finding that the result you are getting is quite X times of that. And yes, not only that, guys, you are going to get an in depth test analysis with a proper personalized feedback, which is definitely going to improve your time management and, of course, time exam approach, guys. And yes, this is one of the most iconic feature that you'll be getting study planner, which is properly and precisely designed by the top educators, considering that all the students around the nation at every corner of it, neither born same nor brought same. Therefore, it is going to be wonderfully customized as per your requirement. Okay, because many of the student might start preparing at at the beginning of 11. Many of you might not have even started now, but now you must be planning. So that all, looking all that, we have got a proper customized study plan. Suppose you, if 2 years are left, means you just have entered into class 11, how you should study, how the plan should be there, which all topics are to be taken care of. Or if you are starting at the mid of 11 of, or you are starting for preparing NEET for suppose if you have not done anything in class 11, but altogether you just want to start in class 12, so how the strategy should be followed, everything you are going to get under this study planner. Therefore, the term customized study plan is used over here. And yes, not only that, you'll be getting a bi-weekly reviews. I'm repeating, bi-weekly reviews. And yes, that is definitely going to highlight, I'm repeating, that is definitely going to highlight your progress, guys. Okay, I hope that is very, very clear. So, needless to say, at the end, that just by taking one iconic subscription, you are going to get an easy access of personal coach, test analysis, and study planner as well. I hope this is very, very well clear to you all, guys. Okay, now, guys, you must be having a doubt in your mind like whether to go for plus subscription or for the iconic one. Let me tell you, this iconic one, guys, acts as a cake with the icing because whatever you are supposed to get under plus subscription, everything is there in iconic one. But these are the additional features of it. You'll be getting personal coach, study planner, expert guidelines, and of course, an in-depth test analysis, guys. Done, done, guys. Now, yes, how much you have to pay? Let me tell you if you go for iconic one. Guys, for 1 year subscription, you are supposed to pay 45,000, and yes, that is going to cost you only 3,750 rupees per month. And if you're a student of class 11, I must tell you that you have to pay 61,000. That is going to come around 2,542 only per month. And yes, whatever the I like, if you look at the iconic features it is giving for having the same, you will have to pay much more than at any other platform. And guys, don't forget to apply this referral code of mine, which is really easy to recall and remember to apply, isn't it? SA10. So whenever you are going to take the subscription, don't forget to apply this referral code of mine. Now, this is something on the screen about plus subscription. Guys, here right from 1 month to 2 year subscription are there on the screen. I just want to tell you that if you want to go for either 1 month, 3 month, or 6 month, there's no point in going for them now. It is better if you plan for them when you are planning for a crash course, and then like especially when you are having very less time left for the exam. But as you all know that we have a lot of time, especially for dropper and 12th, you must go for this 1 year subscription by paying 27,000. That is going to cost you only 2,252 rupees per month. And guys, if you are in class 11, I would tell you that you should go for 2 year subscription. Priyank, welcome to the class, dear. How about you, Priyank? And how about your studies, dear? Yes, guys, if you want to go for 2 year subscription, you are supposed to pay 32,400. That is going to cost you only 1,350 rupees per month. So, needless to say, at the end, this is my referral code. Whenever you are going to take the subscription, please apply this. Okay, I'll be taking extra care related to your queries. Okay, don't worry for that. I'll be there. So, guys, this is the time to start for which you all are waiting for since long. But before we start, I just want to tell you that take few seconds and share to all your friends. Ask them to be online. Hi, beta. Hi, Priyank. How about your studies? So, do you know what we are going to study, Priyank, today? Share to all your friends so that they also can watch it. They also can be benefited out of this video, guys. Okay, so let me start. This is the second lecture under GOC. Previous lecture, I taught you guys about inductive effect. You must watch it if you have not watched it. So this GOC stands for General Organic Chemistry, and guys, it is very important if you talk about the grammar of organic chemistry. Yes, this general organic chemistry actually plays very important role in order to building up the concept of your organic chemistry, or you can say it acts same to that like grammar to organic chemistry as English, like in English language or in Hindi language or in any language, the role played by grammar. It is that important. Without grammar, you cannot run with that particular language. Same way, without GOC, you cannot strengthen your organic chemistry. Priyank, that's very nice of you, beta. I hope you are going to have a lot of knowledge with today's lecture of mine. And you all guys, come on, share to your friends. Ask them to join it faster. We are soon going to start the class. And those who are watching it for the first time, come on. Subscribe our latest channel. Let's crack NEET UG in English so that you are going to get updated with your knowledge every day before we reach to our goal. Okay, guys. And yes, don't forget to press the bell icon in order to have further notification. Okay, so today's topic is, guys, resonance. And yes, we are going to learn a lot of tricks to draw RS. What is that? Yes, RS is resonating structure. And yes, we are going to learn tricks to compare stability as well. We are going to learn tricks to compare stability as well, guys. And remember, whether you talk about NCRT or NEET, this particular topic plays a major role because as long as organic chemistry is concerned, guys, without GOC, you cannot do anything, isn't it? So, guys, resonance, let me tell you from where the term has been originated. This term was given not by me, yes, but by the Sir K. Kule. I'm repeating, it was given by the Sir K. Kule, guys. Yes, K. Kule. And therefore, most of the time, this particular structure of the benzene, which is drawn here, it is also called as K. Kule structure. So, Sir K. Kule has given this concept of resonance. So this is the benzene structure, guys. It has got three single bond and three double bond in an alternate basis like this. So this compound, if you consider this as one atom, here that bond is not there, but that bond is present between 2 and 3 in this case, and here again. So in this case, what is actually happening? This pi bond is keep flipping between 1 2 or 2 3 or 3 4 or 4 5 or 5 6 or 6 1. This is actually be denoted by this way, by a dotted line. This dotted line tells you that this pi bond are actually in a state of flipping with each other, because the energy required for this flipping is very less, and this flipping is nothing but, guys, resonance. What is it? Resonance. So therefore every double bond actually gets converted into a partial double bond. I'm repeating, partial double bond. Why does partial double bond? Because bond order is more than a single bond and less than that of a double bond. So in case of benzene, this partial double bond is shown by the ring. This is the meaning of ring, guys. This ring actually tells you what? It tells you about the pi bonds. Done? So why this is dashed line, it is shown the same way. Just consider a fan. This is a fan with all its three blades, isn't it? And when this fan is moving like this, what actually, are you able to see the blade? No. What actually you see, guys? You see a dashed line kind of this. This is what tells you that the fan is in a running condition, isn't it? So none of the blade is at its position. Similarly, guys, here in both the two structure, you can see the pi bond very clearly, isn't it? Very clearly. बहुत अच्छे से pi bond you can see. But what happens here? The pi bond keep resonating, and this is how the representation of resonating pi bond. Flipping means what? Continuously they are what? Flipping. That is not what? They are in a state of resonating condition. This is the meaning of resonating. Now, what is this? Like, what are the criteria for this and everything we are going to study in today's class? Don't worry. Okay, so if you really watching this video and going to and must have felt that this is really useful for you, don't forget to like it, and yes, at the same time, please share it. And if those who are new watching it for the first time have not subscribed the channel, please subscribe it also and press the bell icon as well, guys. Now, guys, what is the definition of resonance? This flipping is actually called as the organic chemistry language. Flipping is a normal language. Okay. In organic chemistry, we call this as delocalization. And yes, pi bond were flipping. So pi electron, actually pi bonded electrons are getting delocalized, isn't it? Therefore, we call it as delocalization of pi electron. Is this clear? What do we call this? Delocalization of what, guys? We call it as delocalization of pi electrons. Where? In a conjugated system. What is the meaning of conjugated system, guys? Conjugated system means suppose this is a double bond on this carbon. This is attached with another carbon with a single bond. Now that is further having double bond and is attached to another carbon. Such system is called as conjugated system. I'm repeating, such system is called as, this is one of the example of a conjugated system. We are going to have lot many examples to this class. In this class, lot many examples of conjugation. Don't worry guys. So you have to be stay tuned. Come on, all your eyes on the screen, and should have a pen and a copy, because unless you do that, you're not going to get completely out of it. Okay, I hope it is clear, guys. I hope it is very, very clear to you all, guys. So, all your eyes on the screen, pen and copy in your hand. Done. Now, all your eyes here, guys. These are the two structures which just now we had seen for benzene. And this is how the ring is going to show the conjugation, the delocalization. This ring is actually telling you about what? It is actually telling you about delocalization of pi electron is taking place, because alternate, or you can simply say this pi bond with single bond and pi bond. This is actually what? Alternate system of what, guys? Alternate system of double and single bond, isn't it? Double and single bond. I hope it is clear, guys. Jayanna, hi beta, where were you? Yesterday you came to my class, you joined my class, but at the end of the class, isn't it? Don't you know about the timing of my class? I come live daily. All you guys who are watching me, I just want to tell you that I come live daily at 2 p.m. without any delay. And today I'll be coming live at 5:30 as well. 5:30 p.m. is the time to bring lot of tricky tricks, isn't it? Wonderful, easy click tricks. 5:30 is my punch click timing. I bring lot of tricks to you, easy tricks to you in order to make your chemistry very easy, guys. So I come live daily at 2 p.m. and this whole week is going for organic one. So I'll be teaching you organic chemistry this whole week. So you have to be there. Jenna is asking class 12 का organic chemistry. Beta, res organic chemistry तो basically class 12 में ही है. Because if you ask in class 11, this is what? Nomenclature. Nomenclature, and yes, just general organic chemistry are supposed to be studied in class 11, but we don't give lot of time to that. Most of you are not studying organic chemistry in class 11, though you're supposed to do this inductive effect, resonance and everything in class 11, but you don't do that. So as long as organic chemistry is concerned, whether you are a student of class 11 or 12, ultimate organic chemistry is where? In class 12. Is that clear, Jayanna? So this class is going to be very, very helpful to you, because trust me, you have not studied resonance as you are going to study now. Okay, I can bet that you have not studied resonance as you are going to study now. So all your eyes on the screen, Jayanna, you are going to learn a lot from today's class. Okay, are you ready? Yes, guys, are you ready? Come on, if you all are ready to study with me, just give a thumbs up. That's really nice of you all, guys. So is that clear? This benzene was having what? A conjugated system. It was having an alternate system of double and single bond. That is actually called as conjugated system of pi bond. So this is how the delocalization of pi bond is going. So what is resonance? Once again, I'm repeating the delocalization of pi electron in a conjugated system. Now, guys, what are the conditions required for resonance? Let me tell you. First of all, these are very, very important, guys. Very, very important. See, in terms of MCQ in NEET, they have been asked. Whether you talk about mains, they have been asked many a times, isn't it? You must know this. And yes, yes, yes. Whenever you are going to give your board exam as well, it is very, very important. In fact, for entire organic chemistry, it is important, guys. It is very, very important. And yes, in inorganic also, in chemical bonding, so many resonating structure you are supposed to write down. So it is going to help you there as well. Okay, so atom must be sp or sp2 hybridized. It should be either sp or sp2 hybridized. That means it is very clear that the molecule as a whole, which is having this type of hybridization, must be what? It must be planar. Is that clear? It must be planar. Not only that, guys, unhybridized pure p orbital, all these unhybridized pure p orbital must be arranged continuous and parallel to each other in order to have delocalization of pi electrons. What is the meaning of? Let me tell you. meaning of this statement, let me tell you. So just now you had seen, guys, this is the benzene with all, kind of this sp2 high, all carbon in benzene are what? Sp2 hybridized, where each sp2 orbital is making 3 sigma bond. Now guys, on each carbon guys, there is an empty p orbital like this, and all these MTP orbital are actually what? Parallel to each other. And that is the reason they all actually are involved in what? Yes, they are involved in pi bond. And yes, this pi bond actually keep flipping. This keep flipping means what? Let me draw this one more structure like this. Are you getting it, dear? That's nice of you. So these p orbital are parallel to each other, or you can say they are parallel to the plane containing the sigma bond. So here these two were having a pi bond. Now this two will have a pi bond. Similarly, this two will have a pi bond. Here this two will have a pi bond. They are going to be in alternate with each other, or you can say delocalization of pi electrons are going to take place. Is that clear? Delocalization of pi electron. Why it is happening? Because the unhybridized, this white one, this p orbital are what, guys? This p orbitals are unhybridized. Is that clear? These are unhybridized pure p orbital which are arranged continuous and parallel to each other in order to have delocalization of pi electron. Done. This is actually the actual meaning of delocalization. In this case, these two pi orbitals are overlapping and forming a pi bond. All clear. Done. Done. So guys, let me start here. Pi bond. Yes. What are the type? Let me tell you the type of conjugated system. Type of conjugated system. I told you alternate pi bond. So not only the alternate pi bond is a conjugated system. Remember, type of conjugated system. There are 6 types of conjugated system. Repeat. 6 types of conjugated system. The first one is pi bond and pi bond. I'm repeating. First one is pi bond and pi bond. Second one is between pi bond and which is present in alternate to negative charge. We are going to study them in detail. Don't worry. Third one is pi bond and a free radical. Then pi bond and a lone pair. Then lone pair and positive charge. And guys, pi bond a positive charge. So you can say this pi bond. This pi bond is actually including 5 type of conjugation. First one, pi to pi. Then pi to negative. The second one, pi to negative. Third one, pi to free radical. Fourth one, pi to lone pair, and fifth one, pi to positive charge. Done. Pi to positive charge. And guys, sixth one includes lone pair and positive charge. So this is very, very important. There are five type of conjugation where what is involved? Pi bond, 2 pi bond first one, then pi bond to negative charge, then pi bond to positive charge, then pi bond to free radical, and then pi bond to lone pair. Is that clear, guys? Is that clear to all of you? Done. आगे बढ़ते हैं. Now guys, this is very, very important. How to, whenever you are going to write a resonating structure, you all have to keep in your mind how to write down the, yes, how to write down the resonating structure, which all rules are to be obeyed when you are going to write down the resonating structure. It is very, very important, guys. Just now I told you that there are 6 type of conjugation. Guys, similarly, there are 6 type of, yes, there are 6 rules. There are how many rules? 6 rules, guys. Remember, there are 6 rules. And the sequence is very, very important, guys. But first of all, let me tell you the wonderful rule. of flow of electron. Guys, flow of electron. The first one is what? Flow of electron from high electron density to low electron density. But before this, I just want to tell you, whenever you are writing resonating structure, always remember a thumb rule. No change in sigma bond. And if there is no change in sigma bond, means there is no change in arrangement of atom. No change in, yes guys, no change in what? Tell me faster. Yes, no change in अरेंजमेंट ऑफ एटम. बच्चे आप लोग देख रहे हो. आई नो इट. लाइक इट, share it, subscribe it, press the bell icon as well. Isn't it? Fast, fast. I hope you all guys are going to like it. So do like it. You should share to your friends so that they also be benefited. And those who are watching it for the first time, don't forget to subscribe it and don't forget to press the bell icon also, because this class is wonderfully important for you guys, because you are going to learn the resonating structure. Then only you will able to understand the mechanism which we are going to do as well. Isn't it? So guys, all your eyes on the screen. So first of all, let me tell you the thumb rule of flow of electron. How the flow of electron takes place. Tell me. Tell me guys. First of all, the flow of electron. First of all, the flow of electron is from negative charge. If some atom is having a negative charge, because electron density is more, just now the rule is what? Flow of electron from high electron density to low electron density. I'm repeating, flow of electron takes place from high electron density to low electron density. Done. So from negative charge to lone pair, and from lone pair to pi bond, and then from pi bond to free radical or positive charge. Free radical or positive charge. So I'm just going to give you a click here. Kya? Easy click. Null PPO. NLP O. What is this? Negative charge. Null पीपो. नल चलाओ पानी पियो. नल पीपो. ओके, नल चलाओ पानी पियो. पानी कैसे होता है? नल इधर चलेगा तो पानी ऐसे बहेगा, फिर मैं पानी ऐसे पीऊंगी. सो नल वाले डायरेक्शन में बहना है हमें. सो फ्रॉम वेयर द इलेक्ट्रॉन्स आर रिच विल फ्लो फ्रॉम वेयर द इलेक्ट्रॉन्स आर less in density. So null PPO. This N for negative, L for lone pair, P for Pi for pi, PO for positive, and also for free radical, because there also the electron density is what? Least. Is that clear, guys? Is that clear? Done. So first rule is always flow from high electron density to low electron density. Then guys, second one, only movement of electron. What is this? Only movement of electron. What is the meaning of that? No movement of atom. I already told you there should not be any movement of atom. For example, guys, this is what? CH3, CHO, ethanol. Now, ethanol, you cannot write this as this. Why? Because hydrogen has left its position, that sigma bond is broken and gone to somewhere else. This is actually tautomerism. I'm repeating, it is actually tautomerism, but not what? It is not resonance, guys. Always remember, this is not resonance. Done? Done, guys. So there is no movement of atom, means no breaking of sigma bond. I hope it is very, very clear, guys. Now the third one, octet rule to be followed. Very, very important, guys, for second period. For second period elements, octet rule to be followed. For example, let me give you an example like this. This is what, guys? NH2 group. This is NH2 group. And this one, there is a pi bond. And if you can see that nitrogen is having what? 4 bonds, means it should have a plus charge on it, because the valency of nitrogen is how much? It is only 3. So if it is already it is having a, this is the nitrogen, guys. All your eyes on the screen. सब कोई बोर्ड स्क्रीन पे देखो जल्दी से. That's very nice of you. Welcome, beta. How about your study, Prachi? All good. That's really good. Jenna, where are you? Come on, are you getting this? So, is this clear, guys? Is this clear? So what is there? What is the scenario here? Nitrogen is already having what? Nitrogen is already having four bonds. Can this pi bond come over here? Keshav Mondal. Thank you, ma'am. Welcome, beta. Keshav Mondal. कैसे हैं आप बेटा कैसी चल रही है आपकी पढ़ाई क्या ये पॉसिबल है इज दिस पॉसिबल इज दिस पाई बॉन्ड रेजोनेंस पॉसिबल विद दिस empty orbital here no why because if it is possible then nitrogen has to form what guys nitrogen has to form a pi bond here then here and here what is happening here guys nitrogen is forming it has to extend its octet 5 bond and nitrogen is present where it is present in second period so it cannot extend its octet it nitrogen can not expand its octet. Is that clear? Keshav Mandal, is that clear? All you guys, is it clear? Let me know if it is clear, beta. Done. Now, guys, fourth one. Unlike charge at adjacent position are unstable. Remember, very good. Keshav Mandal is saying that, ma'am, yes, clear. So, unlike charge at adjacent position are unstable. What is the meaning of that? Suppose, guys, suppose there is a resonance you show by what? Here plus charge and here minus charge it is not stable guys because unlike charges are there not stable always remember unlike charge are not stable then the next one is number of unpaired electrons should remain same during resonance guys आप लोग देख रहे हो मजा आ रहा है come on like share to all your friends okay आपका भला हुआ सबका भला होना चाहिए share to all your friends and those who are watching it for the first time, press the bell icon and subscribe the channel. Subscribe the channel. Okay, guys. So every information you will be keep getting. Okay, guys. So now the fifth one, number of unpaired electrons should remain same during resonance. This is very important. Unpaired electrons should not change, guys. It should not change. For example, this particular structure is having how many unpaired electron? One unpaired electron. It won't possible that this also undergo homolytic cleavage in another structure, and in that case, all the methylene will have one unpaired electron. This is not possible, guys. Always remember this particular one is not possible. Is not possible. Is that clear? Wait. एक हाइड्रोजन तो हटा ही दो. Are you getting it? If you are getting it, guys, come on, like it, share to all your friends faster. Jaldi se friends ko share karo, isn't it? So, guys, what will happen here? This is not possible. This is not at all possible. Is it? This is not at all possible that unpaired electrons are increased here. So, it is not possible here. Always remember, it is not possible here. Done. Now the last one, guys, charges should be conserved. Always remember, charge should be conserved. I hope it is clear. Charge should be conserved. Charge should be conserved. No more number of unpaired electron. No change in sigma bond. Only electrons will move. Unlike charges at adjacent position are going to unstabilize the structure. Moreover, octet rule to be followed as long as which all elements are there second period they cannot expand their octet remember second period elements cannot expand their octet done समझ में आ रहा है that's nice of you so guys, type of conjugated system. This is very important. You must know how to recognize a conjugated system. This is very important. Otherwise, resonating structure you are not able to write down. So the one of the most important is to write down to identify the conjugated system. And the first under that is pi bond and pi bond conjugation. Pi bond. Can you see there is a pi bond here? Then a single bond, then a pi bond. Is that clear? This is called as, see, there is a pi bond here, the sigma bond, then pi bond. No doubt, no doubt this is sigma also, but we have to recognize the conjugation system. So we'll concentrate on pi bond first. So here what is there? Pi bond, then sigma bond, then again pi bond. Is that clear? Pi bond, sigma bond, pi bond. Is that clear, guys? Is that clear? Done. So I hope it is very, very well clear to you all, guys. So this is called as conjugated system. Conjugated system. Done. Is that clear? Is that clear? Now what will happen here? What will happen? Let us write down the structure. Because all of them is what? sp hybridization. This one is. Okay. So sp2 hybridization. Here sp2. That is, they are all planar, guys. All your eyes on the screen now. What will happen because of that, guys? Let's have a look here. This pi bond will get shifted over here, isn't it? This will get shifted over here. That will result what? Yes, that will result a positive charge over here. In turn, it will be attracted towards this because that positive charge will ask this, bring your electron from there, isn't it? In that case, this will have a, the resonating structure will look like this, will have a negative charge, then a single, then double, like this, and this will acquire a positive charge. Is that clear? This will acquire a positive charge. Is that clear to all of you guys? Done? आ रहा है समझ में? पक्का? Why it is all happening? Why it is all happening? Because p orbitals are what? They are parallel. P orbitals are what? Parallel. Isn't it? P orbitals are parallel like this. They're parallel like this. And therefore, यहाँ से bond टूटा तो इधर बना. The bond between these two is broken. Then here, first of all, in this case, the bond is like this. In this case, what is happening, guys? In this case, both the electrons are shifted over here, and here the bond is okay forming like this. This is an empty one. The plus charge means an empty p orbital. So this is what actually we mean by delocalization. What do you mean by delocalization? So in this case also, these are at alternate position. So this will shift over here, this will go over here. So this is how, what is happening, guys? What is happening? Pi and pi bond conjugation is appearing. So net hybrid here. How to write down the net hybrid here? See, you don't have to move the position of atom. So make the position, all the atom, write it this way with single bond. Is that clear? Now you can see there was a double bond here, but in this case, between these two, there is a single bond. Here there was a single, but here double bond. So what you will do? All the bonds have got a partial double bond character like this. So this is the resonating hybrid. Always remember that. Always remember, we are going to write down resonating hybrid, which is going to fulfill every condition shown by all the individual structure. So these structures are resonating structure 1 and this is resonating structure 2. Between the resonating structure as they are interchangeable at room temperature because energy required for doing so is available at the room temperature. So they are interconvertible, which is shown by this particular double-headed arrow sign. And then guys, if you talk about the resonating hybrid, that will be shown by this symbol. And yes, guys, there is a negative charge here, but there was no charge in this resonating, this particular structure or in this structure. So therefore, there will be a partial negative charge on this, and on this there would be a partial positive charge. So this is how the resonating hybrid is going to represent. I'm repeating, this is how the resonating hybrid or resonance hybrid will be represented. Is that clear, guys? Now just have a look here. This will have what? This will have what, guys? Atom should not be changed. double bond will be here, positive charge will come over here, negative charge will be here, isn't it? Isn't it? Okay, so this is the resonating structure 1, this is resonating structure 2. And how the resonating hybrid is to be written, guys? How the resonating hybrid is to be written? Yes, there would be a partial double bond right from here to here, isn't it? And yes, guys, there would be a partial, what type of charge? What type of charge to be there? Partial negative, and there would be a partial positive charge. So this is the resonating or resonant hybrid. Is that clear? Remember, there should not be any movement of sigma electrons. That is, all atoms will remain where they are present. Is that clear? आ रहा है समझ में सबको? That's right. Very good. Very good, guys. Let us have a look now. This is something very important, guys, on the screen. What is extended conjugation and cross conjugation? Always remember that this extended conjugation is also called as linear conjugation, guys. And linear conjugation, this is more stable than extended conjugation. Very important, guys. Very important. Very important, guys. Done? Is that clear, guys? Is that clear? It is very important. Extended conjugation is more important, more stable than cross conjugation. So let us see how do they look like. If you talk about extended conjugation, it looks like this. Is that clear? This is what, guys? This is extended conjugation. And if you talk about cross conjugation, guys, this is actually like this. Okay? This is cross conjugation. Or you can say there is no direct conjugation. So here, this one or this one. So you can say that at any moment of time, this can be in conjugation like this, okay? Or guys, it can be possible like this. So at any time, any one of the conjugation will be there. Therefore, you can say that this one and this one, they are not in direct conjugation, not in direct conjugation. And this is what we mean by what? This is by what we mean by cross conjugation. Is that clear? This is actually cross conjugation. And here, guys, they all are in conjugation with each other. Therefore, it is extended conjugation, which is also called as linear conjugation, and it is more stable than cross conjugation. I hope it is all clear, guys. Done. And extended or linear conjugation are more, yes, more stable than cross conjugation. Now, the second type of conjugation, guys, is pi bond and a positive charge conjugation. I'm repeating. Second type of conjugation is pi bond and positive charge. बेटा मजा आ रहा है तो फटाफट से like कर दो. If you are learning it, if you are learning from it, come on, like it. Share to all your friends. Those who are new, please subscribe. And yes, don't forget to press the bell icon. Okay, all your eyes on the screen, guys. Pi bond and positive charge. If positive charge is there, that means it is having a vacant orbital. For example, this carbon is having a vacant orbital like this because it is having a positive charge. Here, this particular one, positive charge, is having a vacant orbital. I hope it is clear. Vacant orbital, and here, guys, pi orbital is there. They are parallel. They are parallel. So here pi bond is forming, and all these vacant orbital, if you talk about, or the p orbital, pi bond orbital are there. They all are what? They all are parallel. Same here, the pi orbital which is forming over here are what? Parallel. Okay, to this vacant orbital. And if it is parallel, then only, guys, what is happening? Then only the conjugation will happen. Okay, and yes, you all remember the order of conjugation was what? Null pepo. I'm repeating, null pepo. This is negative charge. this one is lone pair, this one is pi, and this one is positive charge or free radical. So here what? Positive charge. Okay, so pi bond 2, positive charge conjugation will take place like this. Let me draw it here. CH2, CH and CH2 plus. So this will be the conjugation, guys. So this is first structure. The second one is, thank you Arpita for studying. Very good. So this is what, guys. Here this will be plus charge. Double bond is coming over here. So this is the second resonating structure, and the hybrid can be written this way. First of all, write down all the atom with single bond. Make it partial double bond like this. And yes, in this case, what will happen? Partial positive charge on the 2. Is that clear? Is that clear, guys? Okay, guys. Now here also all the p orbital are parallel. So this type of conjugation will take place. I hope it is all clear now. Now, guys, next type of conjugation is pi bond and negative charge conjugation. Very simple. Pi bond and negative charge conjugation. Now, what is happening here? If it is negative charge, this is a filled orbital. It is a filled orbital, guys. Done. Filled orbital. And here there are p orbital. This is a filled orbital, and they are what? They should be what, guys? Parallel to each other. They should be parallel to each other. Now again, null pepo. I'm repeating, null pepo. So from where to where? Negative charge to pi bond. Yes, the transfer will be from where to where? Negative charge to pi bond. I hope it is clear. So in this case, the flow of electron will be like this, will be like this. Negative charge is this side, so it will flow like this will go here. So the first structure, the second one will develop a negative charge like this. There will be a double bond like this, isn't it? Negative charge और फिर बाद में इलेक्ट्रॉन देने के बाद positive charge, so there won't be any charge. Done. Done, guys. So the resonating hybrid will be written this way. First of all, what you do? Yes, yes, yes. Make a single bond like this. Partial negative charge. Here also partial negative charge. So in case of pi bond and negative charge, partial negative charge will be present on both. And just now you had seen that in case of pi and positive, plus charge, partial plus charge was present on the both. So is this clear? And when there is a, yes guys, is this clear? Is this clear? When there is a pi and positive, plus charge, partial plus charge. When there is a pi and negative conjugation, minus charge. I hope it is done. Same thing, this will flow here, this will flow here. Done. Now the next one is pi bond and lone pair. I'm repeating. The next one, guys, is pi bond and lone pair. Lone pair, remember, there will be very few example under this, isn't it? So all your eyes on the screen, guys. In this case, nitrogen is having a lone pair. Let me redraw it. This is the lone pair, guys. This is the lone pair. Wonderfully, wonderful. This very wonderful topic. All your eyes on the screen, because few more things you will be learning from here. Share to all your friends. Like it if you are watching it. And share to all your friends. That's really nice of you guys. Have a look on the screen. Let me take a white pen here. So guys, I just now told you the flow of electron will be null pepo, negative, then lone pair, then pi, then positive or free radical, isn't it? So lone pair is this side, lone pair is this side on nitrogen, pi bond. So lone pair 2 pi bond flow will be there. So this will go over here, then that will, yes, that will make it go on this. So this is the first resonating structure. The second one will be written as this way. This particular one will have a double bond. As lone pair are lost from it, gone to the neighboring one, so there would be a positive charge. There would be a positive charge. So this is the second resonating structure. Meeta Malik, welcome to the class, dear. How are you and how about your studies? कैसे चल रही है पढ़ाई आप लोगों की? So, guys, just if as long as you are supposed to write on the resonating structure, what you have to do, simply write on all the atoms on its place and just attach them with a single bond. Fine, chal rahi hai. This like is for you for studying finely. That's really nice of you. And just draw a partial pi bond like this, partial double bond like this. Yes, and this will have a partial negative charge. This will have a partial positive charge. And always remember, guys, always remember, whenever lone pair are participating, this is very important fact I'm telling you. Whenever lone pair are participating in resonance, while calculating the hybridization, lone pair won't be included. Meeta Malik, ma'am, you teach so well. Ma'am, thank you so much for teaching us, ma'am. You're welcome, dear. And thank you for this compliment, beta. Thank you so much. So all your eyes on the screens. So what is the hybridization on this nitrogen, guys? It is sp2. I told you lone pair won't be counted. Something very important, guys, because this type of mistake we always do. We always do. Whether you talk about NEET or you talk about J mains, such MCQs have been asked so long, since years, that they have been asked for years, guys, that which of the following represent the correct resonating structure, or what is the hybridization of the underlined atom. There we make mistake. Always remember, guys, always remember. Sudha beta is saying that I'm late, ma'am. Sorry, no worries. You can record the video. You can watch it very well. No problem. You can see the recorded video, isn't it? Okay. Download the video after this live class. You can watch it. But whatever the left, you can watch it live also. No problem. And ask your doubt if you have any. So welcome to the class, Sudha beta. Okay, all your eyes on the screen, guys. All your eyes on the screen. So this is what, guys. This is what I was telling. So the hybridization on this nitrogen will be sp2. Remember, whenever you are looking for hybridization, the lone pair won't be considered. I'm repeating, the lone pair won't be considered. Is that clear? So the hybridization on this nitrogen is sp2. This is very important, guys. Okay. Okay, so whenever the lone pair are there in conjugation with any system, whenever for finding the steric number, we are not going to count that lone pair. Okay, it is very important. If lone pair is in conjugation system, then steric number, in order to find the steric number, that lone pair will not be considered. Now, guys, pi bond and free radical conjugation. Let me tell you, if it is a free radical, this will have a electron like this, or you can say that this will have an orbital which is half filled. Orbital which is half filled. Is that clear? If it is a free radical, it will have an orbital with a half filled electron, which is very much parallel to the orbital like this. Is this clear? So pi bond and free radical, just I told you, the flow of electron will be null pipo. I'm repeating, it will be null pipo. N for guys negative, L for what? Lone pair, pi for pi, and this for positive or free radical, isn't it? So pi bond to free radical, the flow of electron will be from pi bond to free radical. Okay, and why is this possible? Because all the orbitals are parallel. Is that clear? Now what will happen over here? They will undergo, this pi bond will undergo a homolytic cleavage. Then after that, all of them are going to have, yes, half filled electron like this, and these two will soon guys, these two will overlap with each other. Okay, so the first structure will be like this: CH2, CH double bond CH. So this is the first resonating structure. and the second one will be same to this one. Is this clear, guys? Is this clear? This is the second resonating structure between the two free radical, and how it is shown. This flow of electron here, it is a fish hook arrow. This is what we call, we call it as fish hook arrow. So always remember this sequence, null peepo. When you have water from the tap, suppose this is the tap, water coming from this, and the one who is thirsty, the one who is thirsty have the water. Similarly, from water to the thirsty. Similarly, from more electron density to less electron density. So, null peepo. Null peepo. Okay, Ekagra, welcome to the class. How are you guys? How about your studies? So guys, now the next one on the screen, lone pair and positive charge conjugation. I'm repeating, there is a lone pair and a positive charge conjugation. Here the lone pair, there is a positive charge means there is an empty orbital. Is this clear? Lone pair and empty orbital. So what will happen? Again, you have to remember the sequence null p O नेगेटिव देन लोन पेयर अब तक तो याद हो चुका होगा सबको वी आर डूइंग इट फ्रॉम सिंस लॉन्ग सो यू मस्ट हैव लर्नड इट pi and this is what either positive or free radical. So here this electron will flow from lone pair to positive charge, isn't it? The electron will flow from lone pair to positive charge. Okay, guys, is that clear? So this will flow like this, guys. And yes, this is the first structure. Then the second one will be CH2. There is a positive charge that after the bond formation, the positive charge will go. But yes, this oxygen will have a positive charge, isn't it? And such type of this very, very important, guys. Very, very important. Why it is very, very important? Why it is very, very important? Such type of conjugation you must have observed many a times under the name back bonding. I'm repeating, back bonding. You must have heard this back bonding many a times. Didn't you hear back bonding many a times? Yes. So what is back bonding, guys? Vacant orbital containing atom, vacant orbital containing atom and a lone pair containing atom should present at adjacent position and will donate its electron to form a coordinate bond. So how it is shown, guys? This particular bond actually shown by this. It will be shown by a coordinate bond. Such bonding is called as pi bond. I'm writing down that statement, guys. Yes, what is this? Vacant orbital. I'm repeating, vacant orbital containing atom and lone pair containing atom present at, they should be present where? They should be, remember, they should be present at adjacent position, guys. Present at adjacent position. I'm repeating, they should be present at adjacent position and will donate its electron and form a dative bond or a coordinate bond. I hope it is all gone here. This is very, very important type of conjugation. So not only organic chemistry, in organic chemistry को भी resonance build up करता है. So lone pair and positive charge conjugation. Is that clear, guys? Is that clear? Yes, if it is clear, let us practice it. Let us practice it. Which is more stable, guys? Tell me which structure will be more stable. Come on. Participate in and answer in the chat box. Participate in it. Answer in the chat box faster. Yes, out of the two structure, which is more stable, guys? Which is more stable? There is a lone pair. Remember, there is a lone pair here. I'm waiting for your answer in the chat box. This is what? This is what, guys? MTP orbital. Yes, There would be a back bonding. Back bonding is going to stabilize it. So due to back bonding, guys, due to back bonding, this particular structure will be more stable, isn't it? Due to back bonding, this particular one is going to be more stable. Now what is happening here, guys? Which is more stable in this case? Tell me which is more stable. No doubt this has got lone pair. This also has got lone pair. There is an empty orbital due to plus charge. Tell me which is more. Yes, stable. Tell me. In both the case, back bonding will take place. Always remember. But guys, in this case, the back bonding is taking place between 2p, here 3p, 2p. So this will have an effective back bonding. So this is more stable. बहुत important है. This question has been asked many a times in NEET. Isn't it? Very important question, guys. Which is more stable and why? Because of the effective back bonding. Why? Because the size of 2p orbitals are same. And remember guys, similar the size, similar size, yes, more will be the overlapping. So here, filled orbital of fluorine and empty orbital present on this carbon will have an effective overlapping. Will have effective overlapping. Therefore, this is more stable. Wasn't it a wonderful question? Well done, beta. Well done, and welcome to the class. Abhi aa rahe ho? No worries. You can watch the recorded video. No problem. All your eyes on the screen now, guys. Which is more stable? Let me know which is more stable. यहाँ पे plus charge था. Here there is a negative charge. All your eyes should be open. Which is more stable? Let me know faster. Tell me which is no. See, guys, you know that there is a negative charge. Null people. What happens during null people? -2, lone pair, then lone pair to pi, and then positive charge or free radical. In other words, empty orbital. Do you find any empty orbital here, guys? Yes, this d orbitals have, this chlorine has, they have d orbitals. They have what? They have empty d orbitals, isn't it? Therefore, negative charge to empty orbital. Yes, yes, resonance is happening here. But there is no empty orbital, guys. No empty D, because fluorine belongs to what? It belongs to second period. So no empty D orbital. Is it? No empty D orbital. Done? Is that clear? Therefore, guys, because of the vacant d orbital, negative charge and vacant d orbital resonance, this is more, yes, more stable. I hope it is very clear to you all, guys. Let's have a question now on the screen. Now, can you tell me which structure will be more stable? Fast. Tell me. There is a positive charge means empty orbital. Here there are lone pair. Lone pair यहाँ पे भी है. What is happening now? Lone pair are present on both. What is happening? Tell me. Tell me. Positive charge. Yes. Okay. What will happen? Null people. Okay. So lone pair and positive charge resonance is there. So from here also, after this, what is going to happen? There will be a positive charge develop on where? Yes, on this oxygen. So this is resonating structure 1, this is 2. Here there will be a positive charge developed where? On nitrogen, guys. And out of nitrogen and oxygen, which is more electronegative? Yes, guys, oxygen is more electronegative. So remember, guys, positive charge will be more stable on the one which is less electronegative. Positive charge is stable on the one which is what? Which is less electronegative. I hope it is done. Akshita is all getting this. Very good, beta. Now, guys, solve this. Tell me which is, all you guys, Tell me which is more stable in the structure being shown on the screen. Faster. I'm waiting for your reply. Tell me faster. See, guys, S orbitals have empty d. S have empty d orbitals. That's really nice of you. In case of oxygen, as it belongs to second period, so there is no empty d orbital. Is that clear? There is no empty d orbital, whereas S have empty d orbital because it belongs to where? It belongs to third period. Is that clear? Is that clear, guys? Is that clear? आ रहा है समझ में? Done. So which is more stable? Yes. Which is more stable? Because of this, it is more stable. So negative charge, lone pair empty d orbital, negative charge, empty d orbital resonance, it is more stable. Done, guys. Hope you really learned a lot from today's video. No worries, those who joined the video late, you can yes download it, and yes you can watch it. Isn't it, guys? Isn't it? And yes, whenever you are going to take the subscription, do apply the subscription code of mine. This is referral code of mine, is very easy to remember. SA10. Those who are watching it for the first time, please subscribe the channel and press the bell icon as well in order to have further notification. Hope you really like the video. So please like the video, share the video so that all your friends can watch it. So thank you, Beta. Thank you so much for watching the video. Happy studies and smart studies. All the best, guys.